Anybody knows what is a table? What's a table? Simple table. Yeah, collection of rows and columns. Okay, anything else? Collection of data, yes, of course it's there. Rows and columns. Yes, that's right, Madhu. How do we read the table? How do we read the table? We look for one particular value and then find its corresponding other values, right? Let's say we are looking for this particular value, the first column, and then read its corresponding other columns. And these other columns values are actually related to the first column value. There is a relation between the first column value and other column values. Okay. And how do we search a particular element in the table? Just scan it for the required key in the first column and then read its corresponding values. First scan the corresponding key in this column and then read the corresponding other column values. This is how you do. Is it okay? Now what happens if the number of keys or number of rows are huge in this table? It will take a lot of time, right? It will take a lot of time to scan all these things. And we are assuming here that other things what you do is you sort the keys in increasing order or decreasing order, then you can scroll it fast and come to the particular key and read the values. This is how you do even in Excel, right? But what if sorting is not possible? If sorting is not possible, then what will you do? You'll do linear scan of this table, right? Now there is one more interesting scenario that you divide the table into many subdivisions you can do. Now suppose that you have this table and the key ranges from 0 to 10,000, or say 1 from 10,000. Key range is 1 to 10,000. Then maybe you can allocate one row for each key in the table. In that case you will need 10,000 rows. Okay. But I tell you that only some of these keys actually exist in the table. Not all keys exist in the table, only some of these keys exist in the table, but the possible range is 1 to 10,000, and sorting is not possible. sorting is not possible. These entries will come in any random order and you just need to store them as they come. Okay, so there are two options. Either you take 10,000 row table and as and when this key value pair comes, put it into the table at appropriate place, one option. And second option is just insert them one after another, irrespective of any sorting, irrespective of their position. As and when they come, just keep on adding it to the table, just one after another. Getting these two options? Are you getting these two options? First option is that you keep 10,000 rows in the table, and whenever a key comes, put its value at its appropriate position, because you have fixed position for each key. Okay. In this case you will need huge space for 10,000 rows. Is it okay, Ritu? Second option is whenever a key comes, put it into the next available space into the table. So key 1, then after this let's say key 800 comes, and then key 50 comes. So as and when keys are coming, just keep on adding to the table. It will require least space but huge search time, long search time. This is second option. Agreed? Now there is third option. And the third option is I divide this key range, which was 1 to 10,000. I divide it into some groups, say 100 groups. So first group will be 1 to 100. Second group will be 101 to 200. Third group will be 201 to 300, and so on. Okay. And then I store only one group in one table. First table will store 1 to 100. Second table will store 101 to 200. Third table will store like this. Yes, indexing sort of. Indexing is a bit different, but okay, so we divide it into some groups. Okay, so how many tables will be required now? How many tables will be required? 100. 100. 10. Divide 10,000 by 100 and answer will be 100. Okay. Yes, 100 buckets you can say we divided. And what was the formula we used for selecting the bucket? Key divided by 100, right? This is a formula with which we will identify the table in which we are going to add. Okay. This formula is actually known as hash, the hash function. Here my hash function is divide the key by 100 and you will get to know the particular table. And now in this table, add the keys as and when they come one after another using the second option which we discussed above. Okay. So you will have to do linear search only for 100 elements, not for 10,000 elements. First of all, divide this key by 100, go to that table, do a linear search. Okay. Now this is one way of looking at the hash table. If I combine all these things, then this is what I mean by hash table. I have a hash function. Apply the hash function over the key. You will get to know the which particular table it belongs to. Go to that table, do a linear search, and you are done. Okay. This is one way of looking at hash table. Now yes, it will reduce searching time. Can we say that in both cases we need same memory space, but takes less time to search? Yes, in this case it is taking same memory space, but now I'm going to modify my structure, hash table structure, and we will reduce the memory space as well. Okay. Now let's see what we can do. This was one way of looking at the hash table. I'm modifying this structure little bit, and it will reduce the memory space. So let me draw like this. Now this is my table. I have only keys here, or rather I have only group numbers here. How many groups were there? 100, right? In the previous example. So assume there are 100 groups here, but only group number is there in this. Now I'm not having memory for each group. Sorry. So what I'm going to have is a structure something like this. You understand the concept of linked lists. So what I'm going to do is we add an entry only when a key comes for that group. Anyway, we were doing linear search there. Linear search we can do in the linked list also. Okay, so when, let's say, you get a key 500, or let's say 504. Suppose you got 104. So suppose key came as 104. Apply the hash function. We got to know the group number, which is 1. Go to that group number. Now you know key number is 104. Okay. Search in this linked list. Is this key 104? If yes, pick this value. If no, come to the next. Check if it is 104. Yes, then pick the value. If no, go to the next, and so on. So space will also be allocated only when key comes. We are not having space for all the keys at the initial time itself. Okay. So memory will be allocated only at request. This will reduce your space requirement as well. Is it right, Nikunj? How the values are stored simultaneously in HashTable at first time. Okay, let's say you are going to add an entry for key 105. 105 divided by 100, you will get the group number 1. From this group number, come to this linked list. Search for this key. If it already exists, then update the value. Otherwise, add a new block here for 105. So that's why I was saying memory is allocated only at requested, only when it is required, not beforehand. One block for one key. That's right. In this example, we have one block for one key value. And that is the second point. Then it will increase the time to allocate the memory, because whenever we want to insert, there will be a memory allocation and we are allocating memory for that, and then only we are inserting the key value pair. It will increase the time. That is what the life is. But we can optimize it further. And how optimization is done, that we will see next. This was one way of storing key value pairs. Second way, first way was like this. Second way was like this. Now we will discuss the third way. Third way can be, and although I'm using the same picture, but I'll draw. Third way will be that there will be group index 1 to 100. These all groups will be there, but instead of allocating memory for one block, one key value, now I allocate the memory for 10 blocks simultaneously. Okay. And we have a pointer for the next block. And so on. You getting this point? Earlier we allocated memory for only one key pair. Now we are allocating memory for 10 key value pairs at the same go. These are all sequential. 101, 102, 103, 104, 105 and so on up to 109 or 110. This will have 111, 112, 113 or maybe 151, 161. So whenever a key value pair comes to be inserted in this table, we check if the block exists for this particular entry, then okay, go to a particular place in that block and put it there. Otherwise, allocate a full new block. Suppose very first time 104 entry comes. Okay, so you will allocate this block from 101 to 110. Put the entry at the 4th position in that block. Next time 105 entry comes, so block already exists for that. Go to the 5th place in this block, put the key value pair there. Next time 151 entry comes, block does not exist, so allocate the new block. Go to the 1st place in that block, put the key value entry pair there. Is it okay? Now suppose very first time the key 104 comes. Okay, and this is the block for, let me write it, 101 to 999, or this was 100 blocks, 199. Okay, you came here, got the group index, and you are checking if the block exists, one block for now 10 elements. This block is going to store the entry from 101 to 1110. Okay, this block contains the entries for 101 to 110. You got the key 104. You know that 104 will exist here only. So go to the fourth index of this block, put your key value pair there. Right? Is it clear, Madhu? Now next you get the key 105. So how will you do? Again get the group index. This time you know block already exists for 101 to 110. So go to the fifth place in that block, put your key value pair there. Okay? And third time you got the key 154, say 154. You checked 154 does not belong to this block. What you will do, allocate one more block for the values 151 to 160. Okay, and put your key value pair at the fourth position in that block. So there, in this way, you will compromise upon the space allocation, space required and time required to search a particular entry. In this case, space requirement was very efficient, but time taken was bit longer. Okay. In this implementation, space was huge, but time was very optimized. Okay, so we have different options which require different space and different time constraints at different levels. Right? These are three options. There are any further more options are also there. Yes, I am coming to that now. When to use when. For this, you have a class available in Java that is HashTable, which makes your life very easy. Okay. You just need, using the HashTable, you just need to know how to add an entry into the HashTable, how to get the value for a particular entry from the HashTable. The internal implementation, which option to choose, that is all hidden from you. That somebody has implemented when this class was developed. So you need not worry about the space and time constraints. It will choose the which particular option dynamically. Dynamically means even these structures get changed at runtime depending upon how many entries are there in the hash table, so as to give you an optimum time efficiency when you are searching for a particular key in the hash table. Okay. And these hash tables are used at many places in our world, even in network system, even in database system, even in operating systems. Unix operating system uses it a lot in its file system. In network system, routers uses this kind of data structures a lot for finding the packet routes. Database system uses it a lot for its cache system, for its indexing system. So you do not know how a hash table is going to be implemented if you are using that class. If you are using that class provided by Java, hash table. But of course you can implement it yourself also. Okay, so this was the concept behind the hash table. You should know what actually happens when we are using the hash table and how they are efficient compared to with respect to simple tables. Okay, that is more important to know rather than memorizing the APIs provided by hash table class. Okay, and if you know how to create an object of a class in Java, hash table is no more different. You just need to create an object of hash table class, use its available methods, and you are done. Okay. Now I will proceed to Java provided hash table. And let's see the hash table class in action. First of all, if you want to use the hash table, you will have to import them. Okay. Say import Java util hash table. You can create an object of hash table. The key will be of string type, value will be of integer type. You can add the entries into the hash table using the put method. So I'm adding 5 entries here, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Okay. If you want to traverse over the hash table, you can get the keys which will be returned as numeration. So I have a numeration of string names. I got the keys of the hash table here. This numeration gives you the facility to fetch the next element and to check is there any more element left in the hash table. So say name, while names has more elements, fetch the next element, it will give you the next key. You got the key, now using this key get the value. So say name numbers dot get. The hash table dot get method is to get the value of this particular key, get it and just print it. This is basic mechanism of hash tables, very basic thing.